Alrighty guys, this is your review video to talk about ways to represent relations. There are 5 different examples here that we are going to go over. Please remember that if you are copying these down, turn this in with your homework tomorrow, which is January 10th, in order to get extra credit on your quiz. So the first one that we are going to go over is ordered pairs. Ordered pairs, if we look at the domain and the range, remember the domain is my x values. So my domain in this case is -1, 0, and 2. And remember, we write that as a set, and we write it from least to greatest. So my domain is -1, 0, and 2. For the range, those are my y values. So that's going to be 2, 5, and 7. So remember, I write those again in set notation from smallest to greatest. So 2, 5, 7. And then remember, a function, when we're looking at unordered pairs, we are looking for any repeat x values. Because we have 3 different x values or 3 different inputs, it is a function because we do not have any repeats. Let's go ahead and move on to the second example. We are going to move over to tables. With the table, remember, we are doing the same thing that we just did. The domain is our input, our x value. And so we are going to look for those and list them from smallest to greatest. So I have -2, 0, and 3. Please remember, we do not write a value more than once in our set of domain or our set of ranges. So even though that there is a 3 written twice, we only indicate it once up top at the domain. Remember, our range is our y values. And so for our range, we're doing that same thing, listing them from least to greatest. So we have -4, 1, 2, and 6. Then for our function, we're looking for any repeat x values. So if we look here, we have a 3 listed twice in our x column. So because we have that 3 listed twice, it is not a function. Alrighty guys, for our third example, when we look at the mapping diagram, remember this is a combination of the ordered pairs and the tables. The left-hand circle, or oval rather, is going to be your domain, and the right is the range. So when we list our domain, we're just listing the values that we see there. So the set is -7, 0, and 3. The range is the values that's on the right, so that would be 1 and 2. Then we're looking to see if each individual x, or the values in the domain, has one y answer. So if we look, -7 only goes to 2, so that one's okay. 0 only goes to 2, so that's okay. And 3 goes to 1. So because they each have their own unique output, it is a function. So let's go ahead and look on the example for graphing. If we look here, we have a closed circle shape, and if you remember today what I had talked about, when we do the vertical line test, this is a special case. So remember, our domain is going to be the x values. So I need the furthest point to the left and the furthest point to the right. So if we look here, these are my boundaries for the domain, for the x values. So my x value can be from -4 to 1. So I have -4 is less than or equal to x, which is less than or equal to 1. And remember, that is just saying that the x values can be in between -4 and 1. For the range, I need the lowest point and the highest point. And remember, we go from least to greatest. So my range is -2 is less than or equal to y, which is less than or equal to a +3. When we go through for our graphs, remember to check to see if it's a function or not, we use the vertical line test. That means I'm going through and I'm using vertical lines throughout the graph. So if we look at this example, we can see here there are 2 points, so that won't work. Here there are 2 intersections. So any place that there are 2 intersections along that vertical line, that immediately tells me that it cannot be a function. And remember, closed shapes, so if you see a circle, a triangle, a square, a rectangle, a hexagon, an octagon, a dodecagon, all right, whatever you see there that is a closed figure on a coordinate plane, that is not going to be a function because it will never pass the vertical line test. The last example that we're going to go through and cover is equations. We have gone through, and today we talked about an equation and that we needed to graph it, all right? So if we think about it, if we look at our graph by either pulling up Desmos or a graphing calculator, you can go ahead and observe the domain, the range, and then see if it's a function or not. So I went ahead and graphed this on Desmos, and if you can see, the graph on the right is the result. Y is equal to x squared minus 1. So if we look along the x-axis, which would show us our domain, we go through and we see that I can put in negative numbers, I can put in positive numbers, and I could put in 0, and I can get a result. So my domain is going to be all real numbers. The range, however, if I look along the y-axis, right, that's up and down, if I look along that axis here, it stops here. That value is -1. So my y values say that anything is greater than or equal to that number since it is above -1. The last thing we need to check is if it passes the vertical line test. So we go through and we go ahead and insert our vertical lines throughout the picture. I know, these are great straight lines. And then if we look here, they intersect only at one point on each vertical line. So yes, this equation, y is equal to x squared minus 1, is a function. This is the end of the video, okay? These cover the different ways that we can represent relations and how to determine if there are functions or not. Please also remember to look over your coordinate graphing packet and your other notes that we did yesterday, that we did on Thursday, Friday, and today, so that you can be best prepared for your quiz tomorrow. That's all I have for you, so hopefully this has helped you review for your quiz.